Welcome to Study Loop.
In this problem, we're given a beam that's pivoted at one end and has three loads acting on it. One load acts at a distance of 1 meter from the pivot and makes an angle of 50 degrees from the center line of the beam. The second load acts at a distance 1.5 meters from the pivot point and makes a angle of 30 degrees from the positive x-axis. And the final load acts at some unknown distance, and it acts vertically or perpendicular to the center line of the beam. And we're asked to find what this distance is for this beam to remain in equilibrium. So each of the loads has a magnitude of 200 newtons. So the first load, we can figure out the torque that it exerts around this pivot point. So the vector from the load to the pivot point is here, and the angle that it makes is 50 degrees. So we can take 200 times the moment arm times the angle of between the moment arm vector and the load vector, and that gives us 153 Newton meters. Again, I've defined positive to be clockwise, so it creates a moment torque in this direction. Now, the second load again has a magnitude of 200 newtons. It acts at a distance of 1.5 meters, and it makes an angle. So here's the vector from the point of application of the load to the pivot point, and it makes an angle of 150 degrees in there. So we get the sine of 150, and so this just becomes 150 Newton meters. Now the last load acts again, has a magnitude of 200 newtons, but it acts at some unknown distance d, and it makes an angle with this vector of minus 90 degrees. So that gives us minus 200 d Newton meters. Now the sum of all these things needs to be 0 for this to be in equilibrium, so we can use that equation to solve for d. And if we see that the magnitude of the load cancels out everywhere, so that actually didn't matter. And if we plug all our numbers in, we get that d is 1.51 meters.